this video, we will discuss about defuse the bomb. You have a bomb to defuse and your time is running out. Your informer will provide you with a circular array code of length n and a key k. To decrypt the code, you must replace every number. All the numbers are replaced simultaneously. If k is greater than 0, replace the ith number with the sum of next k numbers. If k is less than 0, replace the ith number with the sum of previous k numbers. If k is 0, replace the ith number with 0. As code is circular, the next element of code n minus 1 is code 0 and the previous element of code 0 is code n minus 1. Given the circular array code and an integer array k, return the decrypted code to defuse the bomb. So what they are saying is that in the input, we are given an integer array code and an integer k. We need to create another array result of the same size as code, and we need to replace every element in this code with some other element on the basis of this k. So if this k is equals to 0, then in that case, the element should be replaced with 0. Meaning all of these elements will be replaced to 0 and your answer will be 0, 0, 0, 0. Right? Now, if in case k is positive, then each element will be replaced by the sum of next k elements. Right? So, if let us suppose this is 5, right? So, what are you going to create? For this 5, the next k elements will be 7, 1 and 4. Right? So, it will be 12. Then for this 7, what are the next 3 elements? So, this code array is a circular array. After this 4, the next element will be 5. And before this 5, the previous element will be 4. So, for 7, the next 3 elements will be 1, 4 and 5, whose sum is 10. Then for this one, the next 3 elements are 4, 5 and 7, which is 16. And for this 4, it will be 5, 7 and 1, which is 13. Right? Now, when our k is negative, in that case, each element will be replaced by the sum of previous k elements. Right? So now in that case, what will happen? So for this 5, what are the previous k elements? 4, 1 and 7, whose sum is equals to 12. Then for this 7, the previous 3 elements are 5, 4 and 1, which is 10. Then for this one, the previous k elements are 7, 5 and 4, which is 16. Then for this 4, it is 1, 7 and 5, which is 13. Right? So this will be our array. So this is what we need to do. So for this, one of the basic and simple brute force approach is that take each element, find out the sum of next or previous k elements on the basis of k, replace it with that sum and return it. And this condition you can put beforehand. Right? So in this case, what you will do is that you will create a resultant vector whose size will be equals to code's size, which we are denoting with n. And initially, we will keep all the values as 0. Now, if your k is 0, then in that case, you can simply return your result, right? Otherwise, you will move forward. Now, you will find out the sum of next or previous k elements for all the elements. So, you will run a for loop of I starting from 0 till n, right? Now, inside this, what you will do? You will check if your k is greater than 0. Then that means k is positive. So, we need to find out the sum of next k elements, right? So, your loop will start from I plus 1 and it will go till I plus 1 plus k, right? Because we need to find the sum of k elements, right? So, this will be less than, not equals to less than. Then inside this, in your result at index I, you will add the current element. Now see, our array is circular, right? So, when you will be at 7, you have to take the sum of 1, 4 and 5. So, how will you do that? So, our indexes are 0, 1, 2 and 3. So, when you will be at this 7, your loop will run as 2, 3, 4. But we are not having a fourth index, right? So, what we will do? We will use the modulo property so that our index j always lies within the range of code. What we will do is that we will do the modulus of j with the size of our array, which is n. Now what will happen? When this j will be 4, then it will do 4 modulo 4, which is equals to 0. So you will get to the first element. When your j will be 5, it will do 5 modulo 4, which is 1. So it will come to this element. This is what we wanted, right? So this is how we can find out the sum of next k elements. Now If our k is less than 0, it is negative, then we need to find out the sum for previous k elements. So in that case, your loop of j will start from what? It will start from I minus k, right? Because previous k elements. But since here your k is negative, so we will take absolute of k. Or you can also do I plus k, but that will create confusion. That is why I have taken absolute here. And it will go till I, and we'll do j plus plus. Why it is going till less than I? Because previous k elements, the current element is not included, right? Now in this, again, in result of I, you will add code of what? Now see, now we want that before this 5, we should get 4, right? Now we want to go at the last index from the front. So for that, what you will do? J plus n modulo n, right? This is what you will do. And at the end, you will return the result. So in any of the case, if let's suppose j is minus 1, then it will be 4 will be added in it, which is n. So it will give you 3, and 3 modulo 3 is 3 only, right? So you will get the last element, right? So this is the brute force approach. Now here we are running a for loop which is running n times, and inside this there are two loops. Either of them will run in one case, and they are running till k times, right? So the overall complexity of this approach is order of n into k. Here k is a positive k. Okay, so can we optimize it further? Can we think of a better approach? So see, I'll tell you. Let me remove this. So if you see here, if let us suppose my array is this, right? Now in this case, for this 5, what are the next 3 elements? 7, 1 and 4, right? Now when you will find out the next 3 elements for this 7, then it will be 1, 4, 5. Now, did you find some pattern? Here, we are having a window which is being moved towards right or towards left on the basis of k. And each time we are moving our window, one element is being removed from the window and one element is being added. For this 5, we were considering this much window. But then when we came at 7, then 7 got removed from our window and 5 got added and our new window became this, right? Now, in our previous approach, we were finding out the sum of k elements at each iteration. But if you see, when my window was here and then I moved here, then do I need to find out the sum of these elements again? I am already having the sum of these elements, these 3, right? And when in the next window 7 is being removed, can't I subtract it from that sum? If I subtract 7 from that sum and then I add 5 to that sum, will I be able to get the sum for this window? Yes. So then that means I do not have to calculate the sum of k elements at each iteration, right? So what are we going to do is, first we will find out the sum of k elements for the first element, which will be this. And then for every element, what you will do, you will remove the first element of the window and you will add the current element to the window, right? So again, what we will do is, we will take a resultant vector of size n, initially all values as 0. If k is 0, we will return it as is. Otherwise, we will start our window approach. So in a sliding window, we always have a starting index and an ending index, right? So for the first element, starting index will be 1 and ending index will be k, right? So we will take two variables, start equals to 1, end equals to k. And initially, we will take the sum as 0, right? Now we need to check that if k is less than 0. So if our k is positive, in that case, this is okay. But if k is negative, then in that case, we have to update start and end. So if k is less than 0, in that case, start will be equals to kth element from the end of the array, right? So we will do n minus absolute of k, right? And end will be equals to the last element, which is n minus 1. So this will happen when the k is negative, right? Now that we have our start and end accordingly, we will find out the sum for the first element. So we will start a loop, which will be I will start from start and it will go till less than equals to end, and we'll do I plus plus, and then inside this, in your sum, you will add the ith index of code, right? So with this, you will be able to identify the sum of k elements for the first element, right? Now what you will do? you will run a for loop again of I starting from 0 and it will go till n. Now inside this, whatever is the sum, that will be the value of ith index, right? So result of I will be equals to sum, because in the first iteration I will be 0. For the first element we have already calculated the sum, so at ith index we will keep the sum, right? Now for the next element, we have to remove the first element of the window and add the next element into the window, right? And we also need to update the sum accordingly, right? So from sum we will subtract the first element of the window, and the first element of the window is denoted by the index start, right? So since start can also go from the end of the array, so that is why we will do start modulo code dot size, right? And then we need to add the next element, right? So in the sum, what we will add, so now the end is denoted by the index end, right? So what will be the next element? It will be end plus 1, right? So in the sum, we will add code of end plus 1 modulo n, right? This code dot size can also be replaced with n, right? So basically we are doing modulo so that our indexes always lie within the range of code, right? And now since we have moved our window forward, so our start will be incremented by 1 and our end will also be incremented by 1. With this, we will be able to find out the answer for all the indexes, and at the end, we can return the result, right? So if you see, here we ran a for loop k times, right? And here we ran a for loop n times, right? So what will be the time complexity? It will be order of n plus k. K is smaller, we can consider it as order of n. So we have reduced our time complexity from n into k to n, right? So let's quickly code it out now. So first of all, let's take the size of code vector. So it will be n equals to code dot size. Then we'll create a vector result whose size will be equals to n, and initially all the values will be 0. Now if k is equals to 0, then we will return the result itself. Otherwise, we will take a start variable which will be 1 initially, an end variable which will be equals to k, and a sum variable which will be equals to 0. Then we will check that if our k is less than 0, then in that case start will become n minus absolute of k and end will become the last element which is n minus 1, right? Then we will find out the sum for the first element. So we will start I from start and it will go till I less than equals to end, and we'll do I plus plus. In the sum, we will add codes I, right? Then we will run a for loop of I starting from 0, going till n, and I plus plus. Now inside this, add the ith index in result, we will update it to sum. Now in the sum, we will remove the first element of the current window, which will be codes start modulo n, right? And in the sum, we will add the next element, which will be denoted by the index end plus 1. So end plus 1 modulo n, right? And then we will increment our start by 1 and end by 1. And at the end, we can return the result, right? So let's quickly run this. So our test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.